Hello everyone, welcome to Lesson 8.2, Example 1. In this example, I'm going to reintroduce some vocab for you before we jump into trying to solve this first example. So just a reminder, a common difference is how much the numbers in a sequence are changing by. A term is the number, it tells you the position in a sequence. Position of a number in a sequence. A sequence is just an ordered list of numbers, and an arithmetic sequence is a sequence with a common difference. Okay? So if we look at our first example, we want to describe each sequence using words and symbols. So if I look, I have 2, 3, 4, 5, and 3 dots mean it keeps going just like that. So if I want to identify my terms, my first term is 2. My second term is 3. My third term is 4. My fourth term is 5, and so on. Okay? If I want to describe each sequence using words and symbols, one of the first things I have to identify is the common difference. Okay? So I want to know how much are my terms changing by each time. To go from 2 to 3, I know I add 1. From 3 to 4, I add 1. From 4 to 5, I still add 1. Okay, so I know my common difference is 1. And if I look, how are my term numbers, so the purplish pink numbers up top there, how are they related to the actual numbers in the sequence? How are 1 and 2 related? How are 2 and 3 related? How are 3 and 4 related? How are 4 and 5 related? So as you think about this, well, if we look at 1, that's our term number. 2 is just 1 more than the term number. And if we look at 2 and 3, 3 is just 1 more than the term number. We look at our third term is 4, which is 1 more than our term number. So I would say our term number is, not a term number, a term, okay? A term is 1 more than the term number. Because my first term is 2, and 2 is 1 more than our term number of 1. Okay? If I wanted to represent that as an equation, so that would be my using symbols, I would say my term number, I'm going to use t. You'll see t used to represent term frequently, equals, and I'm going to say n plus 1, because it is 1 more than the term number. You'll see the letter or the variable n used a lot with sequences as well, okay? Now I'm going to move on to the next one. I want to see my first, second, third, and fourth term. How are they related? So I see my terms are changing yet again by 1. So my common difference is 1. How would I describe this example? I'd say my first term is 7. Okay, so how are they related? Well, 7 is 6 more than 1. Okay, my second term is 8. 8 is 6 more than 2. My third term is 9. 9 is 6 more than 3. My fourth term is 10, and 10 is 6 more than 4. So I would say the terms have a common difference of 1, and the term is 6 more than the term number. So as an equation, all I would have to write is t equals n plus 6. n plus 6. Okay, let's try 2 more. So my first term is 3. My second term is 6. Third term is 9. Fourth term is 12. They're changing by 3 each time. Okay. How are these related? I see 3, 6, 9, 12, and I realize those numbers are all related. I know my common difference is 3, but how are these terms related? 1 and 3, if we did our previous method, 3 is 2 more than 1, 6 is 4 more than 2, 9 is 6 more than 3, 12 is 8 more than 4. So that system doesn't help. So how do I get from our one term to the next? Each term is 3 times the term number. If we multiply our numbers together, 3 times 1 is 3. 2 times 3 is 6. 3 times 3 is 9. Times 3, 4 times 3 is 12. So we know that our term is 3 times the term number. So that can be rewritten as t equals 3n. Alright, let's try one more. We have 7, 14, 21, 28. Hopefully you see how these numbers are related. It's similar to our last one. We have a common difference of 7 each time. And we know each term is 7 times the term number. So my equation ends up just being t equals 7n. And I can test it out. 7 times 1 is 7, so that checks out. 7 times 2 is 14, 7 times 3 is 21, and 7 times 4 is 28. So I know I am good there. Alright, hopefully this helps. Have a good day.